Yeah. So science and tech current affairs. This is part 4 of October. Okay. Now, this is the first one. This is about atomic stencils. Atomic stencils. Now, see. We'll understand why this picture is there. Now, first thing is, you know about nanoparticles. What are nanoparticles? Very, very small size particles at the nano level, they start showing different properties. Now, so let's say this is a nanoparticle like this. It's a 3D structure like this. Now, if you see, now if I have to make a larger lattice of nanoparticles, like I want to make a big chunk of cluster of nanoparticles. For any application, I won't be able to do it using one single nanoparticle. I will need to join them. Now, in the present system, what usually happens that when you have to join different nanoparticles, so what you do, you just send these systems and hopefully they stick at the right place. This is the approach till now. Because they are very small, so say this somehow works, but this has still very limited application. Now, if you want, like if I have to make a cloth, like the example that I give for nanoparticles is nanotechnology is clothes, which does not leave any stain. So for that it is fine, any way it joins it will work. But if I have to make more intricate things, for example, I want to make circuits that are based on nanowires and very small systems. Now I cannot have a way like this where it sticks anywhere. I need a more precise system so that it sticks right at the correct places. Now this was a underlying issue in nanotechnology. Now, this girl that you are seeing, so she was working in nanotechnology field, okay, was a PhD student, and she also used to do pottery. So here she has joined pottery class. Now, in this pottery class, there is a mechanism called stenciling in drawing pottery or whatever. So what they usually do, like if I have to make Mona Lisa on this, okay, now making Mona Lisa in this dimension is very difficult, correct? Now, so what she was doing was she was making a Mona Lisa on a wax frame, and then she will stick this wax frame. After that, she will paint the entire thing. Okay, so entire thing becomes black. Then she will remove that wax stencil. Now what remains? Mona Lisa will be visible to you on the pot. Correct? This is also used by your simple painters. So when painters, when they are painting, let's say a room, and switchboards are not allocated, where the switchboards are not yet put. So what they will do, they use a wooden block like this or a plywood. So they will just put a wooden block like this, and then they will paint the entire thing. Then they will remove this wooden block. So what you will have? You will have this spaces, correct? And this, in this space you put the switchboard. So this is a very simple technique. Now while doing this, because she was also doing nanotechnology research, she thought that this system, this method can also be used in nanoparticles. Now what she and her guide, that is the professor she was under, they came up with was something like this. Now see, of course you cannot paint like this. So what they did, see this. So this is a simple pristine surface or a simple nanoparticle. Okay, now on this nanoparticle they started applying coating of iodine through lasers. Now what they did, laser is very precise, so they were able to coat, see this, iodine all around, correct? So iodine is coated all around except for some places like 1, like 2, like 3. Okay, now these places are left, otherwise it's all iodine stick there. Now they started linking the polymers, or they started sticking the polymer patches. Now these polymer patches will eventually form the long chain of nanoparticles. So now when the polymer patches came, now they cannot stick anywhere where iodine is present, because iodine is not the sticky substance. Like that, if it is gold, if it is made up of gold lattice, then any polymer can stick inside the gold, but not iodine. So this part is gone. Now they can stick only at these points. So in this way, now the polymer patches will attach only at specific places. Now similar polymer patches can be made for another kind of nanoparticle, and these patches can be stuck like this, and in this way we can form long chain of nanoparticles. Understood? Very basic. Okay, so what they are doing, they have now developed a system in which they place it at a fixed location, and now it can form a useful nanoparticle chain, and in this way they can have many different applications, because now it is very precise. Based on beam, I can make sure that which place I want something to stick and which place I don't want anything to stick. So that is what she and her professor came up with. Understood? Started with very simple thing, but this is a very big discovery in nanotechnology. It was not something that was not known to anybody, but these were two things in different fields. One was in art, one was in science, and she was able to correlate them. Understood? Okay. Then let's just read it once. Okay. So see what they have demonstrated. Yeah. So scientists demonstrated atomic stenciling to place polymer patches precisely on gold nanoparticles, giving fine control over their surfaces. Correct? This only we understood. Okay. Now uniform patches let particles self-assemble into ordered 3D crystals. So now if I have uniform patches, correct, patches are not placed anywhere, okay, it is placed like at particular places. Now they can form a 3D structure that is well made, and this 3D structure can be used in many different ways. Then what is atomic stenciling? So it's like using a stencil at the atomic scale. Selected atoms first block parts of nanoparticle, then a polymer is applied that sticks only to the unblocked areas. Correct? As we understood. Then a patterned patch appears exactly where we want. Okay, you need not remember the exact lines of this, but you understand that process and that diagram. Correct? Then this is atomic stenciling. Then how does this method work? So first is masking. Special atoms, example iodine, bind only to certain flat crystal faces of the gold particle and shield them. This you can write down. This is the method. That's it. Masking, and then we are doing polymer painting. A polymer solution is added. It bonds only to exposed gold. Now I can put this entire thing inside a polymer solution also. It won't stick anywhere in the iodine part. It can only stick here, here and here. That's it. So this is the method. This is atomic stenciling. A detailed mains question won't be asked from this. Just this much you need to know. Then now how it is significant? So atomic level control it will give you, okay, can create 20 plus patterns. Example, corner patches, face patches. So these patches can be anywhere based on which part I am covering, which part I am leaving. Now moves nanoscience from theory to programmable building of materials. Fine. Then yeah, applications. So applications can be targeted drug delivery, okay, better catalyst. Basically these are nothing but these are the applications of nanotechnology. Now all these applications will be benefited from this, because now we can form more complex systems. So simply you have to just add one adjective and write whatever applications of nanotechnology you know. For example, they act as catalyst, so better catalyst ban jayega. They act as drug delivery system, so better drug delivery system. Like that you have to change the adjectives, right? That's it. Okay. Advanced electronics and smart materials, all this. Then yeah, Then you come to second topic. इसका seeding कहाँ गया? This is cloud seeding. Cloud seeding. Okay. Cloud seeding, you study an environment, correct? What is cloud seeding? Environment not done. Huh? Okay, yeah, one of the applications of cloud seeding. Basically, see, in very simple terms, what you are doing, see, if there is presence of moisture, okay, in the clouds, now, but the moisture is not enough. If enough moisture is present, then these clouds will have big water droplets like this, which this cloud won't be able to hold for a very long time, and eventually it will fall down as rain. Depending upon the temperature in that region, it can form as ice, it can form as snow, or it can fall as rain droplets, correct? This you understand, simple phenomena of clouds. Now, sometimes enough moisture or water particles are not available. So this big enough water particles are not able to form. Now what you can do, instead, what you will do, you will take a flight like this, and from this you will drop some hygroscopic nuclei. So these nuclei, for example, this, okay, so these iodides, potassium iodide, all these will be thrown in onto the clouds. Clouds are available, they just don't have enough moisture or conditions to fall. They have some moisture, okay, so everything is there, they are just lacking by a bit. Then what you will do, you will drop these nuclei. Now around these nuclei, what will happen, these small water droplets are there na, that are not able to form big water droplet. They will coalesce, they will come together. Now what they will form, they will form a bigger chunk of water droplet that will of course eventually fall as rainwater. That's it. So basically they are providing a surface on which smaller water droplets that in itself are not able to make rain will coalesce there and form bigger water droplet that can fall on earth. So this is how cloud seeding works. Now cloud seeding has many applications. For example, one application you can see that if it's drought conditions, there is not enough rainfall, then you can make this, okay. Now you can also make this, for example, China did this during the 2008 Beijing Olympics. So what they found out, that let's say this is cloud, okay, in cloud they found out that there are small water droplets like this. So right now there won't be any rainfall, correct, but 1 month after this is Olympics, okay. By then these water droplets will have become big, and then there will be rainfall during the Olympics, which you don't want. So what they did, they would prepone the rain. How they will prepone the rain? Again they will send all these hygroscopic nuclei. What will happen? All these small water droplets will coalesce around, and then they will have early rainfall. So before the Olympics only they had very heavy rainfall, and then during the Olympics, because now ye to ab khali ho gaya, water droplets have gone, so now during the Olympics they didn't have rainfall. So this was in 2008, okay. So this is one way. Then there are many other ways. Now the present government in Delhi is trying to use it to control pollution. Now if you know, in pollution there is lot of dust particles, there is PM 2.5, carbon soot, this, that. Now if you might have seen that after rainfall the air clears up. If you check the AQI, even here, even if like right now if the AQI is 40-45, you will see after rainfall it becomes 15-20. So every time there is rainfall, the air gets cleaner. Why? Because all the particles that are suspended in the air will come down with the water to the soil, correct. So that is being done, that is being thought to be done in Delhi also to control pollution levels, okay, that we will have some amount of rainfall, with that we will be able to control pollution. These are the basic uses and the mechanism of cloud seeding. Now let's see. Yeah, so why this is in news? So see, Delhi government partnered with IIT Kanpur to attempt cloud seeding to reduce post-monsoon air pollution. Okay, this is why it is in news. So Delhi government is partnering with IIT Kanpur for cloud seeding practices for post monsoon air pollution control. Now what do experts caution? This you have to understand, that post monsoon has few rain bearing clouds. Now right now monsoon season is gone, correct? We are in October, monsoon is gone from India almost now. So now the clouds that are present right now, they have very few rain bearing clouds are present. Most clouds don't have that much amount of water anyway. So now if they are not rain bearing clouds, then this will be scientifically unsuitable to conduct it using cloud seeding. As I told you, this is not a phenomena that can make rain at any place. Only places where there is clouds but not enough rain bearing clouds, then it can help. Okay, so there are water droplets but not in enough quantity, then this can help. But if there is no rain bearing cloud, then it cannot help, it cannot make waters, correct? So that is why they are saying that it won't work that well. Now what is cloud seeding? So cloud seeding is a weather modification technique to enhance precipitation, rain or snow from existing clouds. Then mechanism is what? So aerosols like silver iodide, this is the main one that is usually used, silver iodide, then potassium iodide, sodium chloride, all these are different kinds of salts. Now or dry ice, that is CO2, this will be dispersed usually by aircraft, act as ice nuclei, will act as a hygroscopic nuclei, making droplets or ice grow in size and fall as rain or snow, correct? As we understood. Now important, cannot create clouds, of course, then works only when naturally formed moisture laden clouds are present. That's it. So this is cloud seeding. These compounds you can remember: silver iodide, potassium iodide, sodium chloride and dry ice. If they give you some other metal and iodide, that also you mark, most of the time it will be correct. Okay. Then what is the status in India? So they have done studies in India. So they did multi-phase studies from 2009 to 2019 that showed rainfall can rise up to 46% under favorable conditions. Okay, then states, Maharashtra has tried this, Karnataka, Andhra Pradesh, all these states have tried it for drought relief. Then global use, so China, as I told you, in 2008 Olympics, UAE, Saudi Arabia also uses it for water security. Okay. Then yeah, where it can help, one is drought relief. Okay, drought prone regions mein we can increase the amount of rainfall. Then air pollution washout. Okay, if there are favorable conditions, scientists are saying there are not favorable conditions right now, but if there are, this can help. Then hail suppression, that is mitigate hailstorms in vulnerable regions. So if there is conditions for hailstorm, so you can prepone it and release the pressure from the air droplets, so there is no hailstorm. Then fog and visibility, similar things as air pollution, same thing you can do. This can be done near airports or highways where navigation becomes difficult. If you know, flights get delayed or cancelled in North India during the winter months. Then this is where cloud seeding can help. Now limitations in case of Delhi's pollution. See, first thing is there is seasonal mismatch, as we understood that in the October to December atmosphere is dry and stable. Okay, cloud quality needs are not being met, as we understood. water laden clouds are not present in enough amount. Then western disturbances. See, rainfall during this time, that is October to December, winter rainfall in North India is because of western disturbances. What are western disturbances? What are western disturbances? ऐसे करके एयर आता है, wind आता है from Mediterranean Sea, and that causes rain in northern India. Now the issue is that this wind is very erratic, so we are never able to guess when this wind will come, when this will stop coming. So now if we don't know when this wind comes and when this wind goes, then it becomes very difficult for us to plan our cloud seeding process. So that is another issue. Then western disturbances are unpredictable. Then this will have a short-lived impact, because if we keep on polluting, that we see in northern India, there is constant stubble burning, there is constant dust from whatever construction is there, okay, from factories. Then what will happen? Eventually, after, like if you continue the emissions, then after 1 week you will have the again similar conditions. Then environmental risk. Now see, silver iodide chemicals that these may accumulate in soil and water. So right now enough studies have not been done with respect to the amount of impact they can have on our water or soil, because it is falling from the sky. Now what impact it can have on the soil in the long term, that we don't know yet. Then accountability. Okay, now if they did this cloud seeding and let's say very heavy rainfall takes place, now who will take the responsibility of this, and there is some flash flood or anything? Okay, so responsibility frameworks, nothing is being designed. Then last is resource trade-off. So we have in India limited resources. Delhi government also has limited resources. Now region specific evidence makes it hard to justify investment versus proven solutions. So instead of this, we have other solutions that can work much better. This will cost a lot of money, and if we continue the emissions, after 1 week we are at the same spot. Okay, but there are many political reasons why government is thinking of this. So there are elections. Okay, like if you know, one thing is getting very famous about Yamuna. Yamuna cleaning is getting in news a lot. So Yamuna Chhat, you know, Chhat is a festival that is celebrated in Bihar and UP. So now during the Chhat, they have to go to the river, and there is some puja that they do, okay, in the river. Now, so they wanted, because there is a high population of people from eastern UP and Bihar in Delhi also, so they want to do this in Yamuna. Now Yamuna is highly polluted. So what the government started doing, they've started cleaning of Yamuna, but of course it's a tedious process. So they have not been able to do it very well. So now they are making different kinds of mechanisms. Okay, for example, they have made the ghat where the Prime Minister will go. They have separated the ghat from the river itself. Okay, and on that ghat they are getting water that is filtered, and then probably the ministers or anyone who comes there will drink and show everyone that water has been cleaned. One more thing they are doing is, all those if you might have seen these AQI meters, you might have seen board in which they are telling the AQI, correct? So where there are centers where that board is there, monitoring station is there, so there they have employed tankers, and these tankers are throwing water whole day. Okay, so what this will do, this will settle down the pollutants there, and there the AQI will reduce. May not be in the whole city, but there it will show that the AQI is in control. So all these measures are being taken. Now that is another measure that they are thinking of doing, not much reliable to do. Anyway, then AWS outage. What is AWS? Amazon Web Services. Okay, last year there was also a prelims question about Majorana chip. In that they had given that Majorana chip is manufactured by AWS. Now that is manufactured by Microsoft. This. So now Amazon Web Services. Now what happened? Amazon Web Services what? First of all, see, if I am a small business, or most internet, almost 32% of the internet, whether apps or websites, is run on AWS systems. So there are big three. Okay, there is Amazon Web Services, then there is Google Cloud, and Microsoft Azure. So these are the three. They control almost 60-70% of whatever you see on the internet. It is being hosted by their servers. See, what are servers? Now, if I am a small business owner, now I want to have my website, now I want to upload certain things on my website, this, that, everything I want to do. Now, if I have to do this, now one way of doing this, I do everything locally. So a small business will have to start the entire IT team, and I'll have to have one entire IT team that will first of all make this entire system, and after that manage this entire system. If there is some issues, okay, it is running smoothly or not, constantly user data also has to be captured. For example, if you might have used any coaching's website also, and if you have clicked here and there, okay, that starts showing in your ads. How that is happening? Because that your interaction is getting recorded. Now sometimes it asks you to sign in, to put your number. So that number eventually gets to them, and then you call. Then you get a call ki join karna hai kya? Okay. So all this is a backend system. For that you will have to employ all these people, but every company cannot do this. So now these three provide all these services at a fixed monthly cost based on your usage. Okay. So now the good thing is, now let's say during the month of April or June there are more admissions. So I will need to increase my IT team because they have to manage much more load. But here if I am being hosted on the AWS systems, now AWS has very large data centers and everything. So what will happen? उस month का मेरा cost थोड़ा बढ़ जाएगा. I won't need to do any other thing. Just the cost will increase slightly. So basically variability is also managed well, and now these systems, now they have developed it so well that they are, most of it is automated. Most of it is automated now. So all the entire systems are not being managed by people. Only people get involved when there is some issues. Otherwise this is a self-running system. They have developed database systems that are self-running. Okay. So that way they do all this. If you might have seen most of the videos also that you see on various websites like the Hindu, this, that. Now if you look at, if you go on inspect and search for the code from where it is being hosted, you will find it that it is being hosted from YouTube itself. That is from the Google servers. That is why you can see those videos. Understood? So these are the services these clouds provide. Most of them are provided by these three, and in these three also 32% is only from Amazon Web Service. This is the largest. Now, so there was one AWS outage that was observed on some day in October. Okay, I think 20th of October. So outage means what? For some time it stopped working. Now if you understand, 32% of your entire internet that you use is based on this AWS. So what will happen? Everything started becoming malfunctioned for some time. That's why there was a lot of hue and cry that was created, because everyone's system stopped working. All these websites, all these apps stopped working. Okay. Now, so that raised concern for different countries that should we have such an important system being held by only these three companies, because it increases our vulnerability. That's it. Now, see AWS. A major outage at Amazon Web Services due to domain name system DNS error blocked access to key services, disrupting 1000 plus sites and apps worldwide. Okay. DNS is what? In very simple terms, see, you type this www dot, let's say, legacyIAS.com. You type this, correct? Now, but this is not understood by the computer. It does not read it like this. Now, this has to be converted into IP. This has to go to an IP, internet protocol, where whatever data or whatever interaction you want to do is stored. For example, you go there, you try to download current affairs PDF. Now it will somewhere be held in some different computer or server. So to that IP it must go. Now who changes it from this to this? IP is a number, if you know, like 11.990, like this it will look. So who will change this from this website to an IP address? This is called DNS. So there was some error in this part. That's why whatever you were typing for that particular website, if you were trying to open it, then it was not reaching the correct data center. Now if it is not reaching the correct data center, what will happen? It will not open and the site stopped opening. Understood? Then what was the impact in India? So in aviation, airline, IT, okay, went out. In different banking also, the Reserve Bank of India said about 10 banks had faced disruptions. Need not remember that. That means aviation, banking, all these sectors were affected by it. 32% of the internet was largely impacted in some way. Then now, who are the main cloud providers? So main players are Amazon Web Services, Microsoft Azure and Google Cloud Platform or GCP. Now why choose them? Now why they choose them? As I explained you, it is much more cheaper than having your own IT team. It is much faster. This is based on cloud computing, much faster also. To start, pay only for whatever you are using. Then scalability is very easy. For example, during demand spikes, as I explained you, April or June. Then provider runs the hardware and security updates, so teams focus on product. Now this is a coaching institution, so what it should focus on? It should focus on teaching students, preparing material for UPSC, rather than making IT team and thinking about website, this, that. So they can focus on the product. Now Amazon have its very big data centers. For example, in very small cities in USA, they have data centers. That means simply data centers are nothing but large number of computers connected on a system. So they have, in small cities, they have very big data centers where there will be many computers. Okay, and these will be holding or the entire data and helping you to navigate through any website or anything that you want. So this is being held by the data centers. One more thing that you can understand, that if you have to go offshore, then also this works very well. For example, let's say I make my own IT team and it is holding a server here, everything is being done here. Now if I expand and I open coachings in, let's say, London also. Now from London, every time anything they have to do, they have to send the entire protocol till Bangalore and then it has to go back. So it will create a lot of lag, correct? And then it also has to follow norms of UK, which websites, what can enter, what cannot enter. Now Amazon have its servers in every country, almost every country, almost every big city. So it is not a problem for them. So easily you can expand. Then this is a trade-off between convenience and dependence on one vendor. Now once you get into one system, for example, if you start using AWS, then it is very difficult to change to Google Cloud because they work on little different systems, this, that. So moving is not easy. Then yeah, so this was the issue that people were saying, that shared control systems, one bad change or update, example DNS, can hit thousands of customers at once. So this is a issue that we have. Few providers dominate and the issues are felt globally. So that is why they are saying that instead what we should start doing is having local data centers and this, that. See, so what we should use more than one cloud, that is multi-cloud. So instead of depending entirely on AWS, for a time being, we should depend on, let's say, some part on Google, some part on our own systems, so all that, or mixed cloud with own servers, hybrid systems. Okay, then build sovereign capacity. For example, we have our NIC, we have Meghraj. So all these cloud systems we also have, but we don't usually use them. So we can rely a little bit on them. Basically distribute it so that your entire site or entire thing does not get switched off. Then make apps portable. This is fine. Then practice resilience is fine. Okay. So this is what you should do. Basically, distribute all around and use your own internal systems. That is no. They basically run your entire website. Now, your website, for example, let's say I pick hindu.com, thehindu.com. This is a newspaper. So how the website of the Hindu will work, how it will look, everything will be hosted on the AWS servers. Even the video that comes, that will be hosted on the AWS servers. The ads that you see on the hindu.com, that also is hosted on AWS servers, though the Hindu is most probably using Google Ads, so it is being hosted in Google Cloud servers. So everything is managed by them, and they also have automated everything. Okay, so basically it is being run like a no man's system. Then when there is some problem, then only engineers come. Okay, everything is taken care of. Then yeah, see, okay, so quantum technologies, quantum technologies, what are quantum technologies? That are based on some quantum properties like, see, basically what we have observed, nanoparticles, you understand, when you go at nano level, the properties used to change. Now the properties were slightly changing in case of nanoparticles. Now if you go subatomic or at the atomic level, so if you go atomic or subatomic, that means, for example, electrons level. So electron is what, 10 to the power minus 15. If you go at that level, that small level, then what we observe, that the classical mechanics or the normal physics that we understood, that stops working, and another kind of physics becomes important there, or becomes the main physics, that is called quantum mechanics. Okay, so basically here classical physics stops working and quantum mechanics takes precedence. Now quantum mechanics have many different kind of physical, it's a different kind of physics, has different properties, this, that. Okay, now basically here what we are doing, see, usually whatever kind of cryptography or whatever you are trying to use as a security mechanism, now you know passwords, correct? So you have passwords. Now password is what? You have some pattern in your mind, based on that you make a password. Now sometimes Google also suggests you a password, a strong password, and it looks like this. It forms no pattern to you, it seems very random to you, but this still has some pattern that Google knows. Okay, so it still is based on some mathematical algorithm. So Google understands this algorithm, based on which it made this password. Now, so every password, everything that you see around, that is trying to secure anything on the internet, it is internet or anywhere, is based on some mathematical formulation. Okay, now that may be very complex for anyone to decipher, or maybe very complex for even supercomputers to decipher, that is different, but it will always be based on some algorithm in most cases, correct? Now yeah, now see, what you heard right now, this is pseudo random numbers. Basically these are the normal passwords, everything that you see. So basically a set of values or elements that is statistically random, okay, but it is derived from a known starting point and is typically repeated over and over. So basically statistically it may seem random to you, but it is always derived from some kind of algorithms. Now see, computer uses an algorithm based distribution and are not secure because they rely on deterministic or predictable algorithms. So because this is based on some algorithm, that algorithm can always be broken down, and then the passwords or anything that you are trying to secure can be known. Understood? It is being made more and more difficult by different technologies. For example, blockchain makes it very difficult, but still it is always based on some algorithm, and you can still tamper with it. Now, so these are called pseudo random numbers. So these are random numbers, they don't have a direct pattern, but this is based on some algorithm. So these are random numbers, correct, but they are pseudo random. Pseudo means not perfectly random, they are still based on some complex algorithm. Now you come to true random number. So scientists in Raman Research Institute, they have developed true random numbers. Now how can you make true random numbers? So now random numbers form a physical process rather than by means of an algorithm. So now what they are doing, they are not relying on any mathematics, they are actually relying on a physical system. So basically they are relying on a natural phenomena that is random by its nature. In very simple terms, a natural phenomena that is random by its nature. So it is not based on any algorithm, it is found in nature. So they are trying to tap into it. Now what it will generate will be completely random and won't be based on any algorithm. Now if it is not based on any algorithm, nobody knows why it is working like this, then what will happen? It can never be broken down, or it cannot be ever breached. Okay, now see this example, radioactive decay of isotopes or airwave static. Now here what they have used, they have used different kinds of particles. Now these have different states. For example, if this is a photon, then it has 1 and 0 both simultaneously. It has 1 and 0. Now when you measure it, then it starts showing 1 or 0, any one of them. This is a property that photon in superposition has. It's a quantum property that a photon in superposition has. Does not matter to you. What means here? Simply that when you try to measure it, initially it has both of them together, 1 and 0. When you measure it through any detector, then it will randomly show you 1 or 0. So we don't know at this particular nanosecond it will show 1 or 0. We don't know any pattern. So whenever we try to measure it, it will be 1, 0, whatever. We don't know. So this will generate a completely random number, because we also don't know how it is working. This is just happening. Similarly, it happens for radioactive decay of isotopes also. So we don't know when what ray will be released at what phase change. So that also we don't know. So based on some physical system, we are trying to generate completely random numbers. Now this they have been able to do. Yeah. So this is Raman Research Institute, Bangalore, has generated true random numbers using a commercial quantum computer for hack-proof digital security. Okay. Then significance is what? This is first major globally relevant output linked to India's quantum mission. Okay. So Indian quantum mission, we have came up with 8,000 crores budget, but it is saying that this is the first globally relevant thing that we have come up with. Okay. Basically here what you need to understand is only what are true random numbers and what are pseudo random numbers. Okay. Then so what are true random numbers? Number drawn from inherently unpredictable behavior of quantum particles. No preset algorithm or pattern. That's it. Okay. Now example, a photon in superposition collapses randomly on measurement. Fine. Property, randomness is not predictable or influenced by this. It's fine. You will understand it better when you study quantum technologies. Okay. Then you will understand these terms. For now it is fine. Now what is this? Yeah. What's new in this method? Now for now we remember only this. So there are two ways. There are two ways to get a system like this, to get a quantum system like this. One is by time separation and one is by spatial separation. Spatial separation is what? When they are placed at far off places so that they cannot interact. Okay, and time separation is when they are at the same space but at different nanoseconds of time. Does not matter to you. For you, you only remember that we can make these quantum systems using two kinds of separation, time separation and spatial separation. Now, most of the time spatial separation was used. In this, we have done it using time separation. Okay, now in spatial separation, in general way you can understand, in space I have to separate them. Then what will I require? I'll require a larger system, correct? At one place I have to put a one, at another place I have to put the other. Here in time separation, I can be it in a small space and just with a variation of time I am able to realize that quantum system. So I don't need very big chunky pura matlab like systems. Okay, so big I don't need, I just need simple systems that will have time separations. Okay, that's it. Then see this practicality, works in everyday settings without large lab rigs, closer to real world applications. So now you don't need very large lab rigs because this is based on time separations that you can achieve even in a small device. Then yeah, how do they matter? So this you can understand. Foundation, see, random numbers underpin passwords. Random numbers are actually the foundation of any kind of password security or whatever, correct? Now random numbers, one way was generating pseudo random numbers, that was based on some algorithm. Now you are generating true random numbers that are completely random. So it will just make our systems much more secure. Then this makes it future ready. Okay, then risk with PRNs. So algorithm based hoga, so then it can always be broken down. This cannot be broken down because this is based on physical system that we also don't understand. If we also don't understand, then nobody will be able to decipher them. That's it. फिर एक word चला गया. This is lunar exosphere. This is a nothing topic. Okay, one topic I kept short because I knew the other will take time. So lunar exosphere, it's nothing. See what they have found. So our, if you know, our Chandrayaan, this that is there in the around the moon. Now why this is in news? See, so what they have observed, this what our Chandrayaan 2 orbiter has observed, that coronal mass ejection is a phenomena done by the sun. Now coronal mass ejection's effect it has felt around the moon. So around the exosphere, that is around the atmosphere of moon. So atmosphere is not the correct term. So around moon whatever space is there, it felt some different kind of pressure. Okay, so what happened? This was sun, this was moon, this is the space around the moon where our satellite is rotating. Now what is observed, that when there was coronal mass ejection, a phenomena by sun. So when there is coronal mass ejection, CMEs, then it observed that the pressure here in the exosphere increased by 10 folds. That's it. So this is the first time they have observed this. Basically, this is the first ever direct observation of a coronal mass ejection hitting the moon. So this proved that coronal mass ejection hit the moon because the pressure suddenly increased by 10 times. This was observed by the satellites, nothing much. So this is detected by CHACE2 on Chandrayaan 2 orbiter. Then date was this. This was the date on which Chandrayaan 2 was launched. See, 10x jump in neutral atom number intensity. Okay. See, confirms long-standing theory that solar storms change the moon's atmosphere. This was a theory for a long time. It is a very natural theory that solar storms, as it affects the earth also, it can also affect the moon. So it will also have effect on the exosphere of the moon. This was theoretically correct. Now they have shown this in reality through their detectors. That's it. What is this? If they ask you, this is CHACE2. What is this? This is a neutral gas spectrometer. Basically, it observes if there is change of some gases, some neutrons, like that. That's it. Yeah. Then that's it. Why does this matter? So space, weather, it's fine. Try this. Done? What do you think? Which one is wrong? Is any statement wrong? No? Okay. Let's see. So first is, in the masking step, iodide ions preferentially shield certain flat crystal spaces of gold. Is correct? This is what it does. What it does then. The polymer subsequently bonds only to unmasked or exposed gold surfaces. Yes, the polymer bonds only to the unmasked. This is correct. Then the method aims to randomize patch positions to avoid ordered self-assembly. This is wrong. It does not randomize patch position. It actually fixes the patch position so as to form a particular self structure. Basically, earlier what was the system? That was forming randomized patch position. Anything was getting attached anywhere. Now because of this system, they create particular spaces. For example, here, 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 here and here. Here only it will get attached. So this will not randomize, de-randomize the patch positions. So this is wrong. Answer becomes A. Then this is fine. Correct? See, this is because right now it is dry and stable with few suitable clouds. So this process is not that possible. And then do this. What do you think? Yes. Okay. So what it says, this is about TRNs. TRNs arise from intrinsic quantum phenomena, not from algorithms. This is correct? Yes. Then they are predictable if the seed and algorithm are known. No, they are not based on any algorithm or seed. Correct? They are not predictable by them. Then the demonstration used a commercial quantum computer. Yes, it's factual. So answer becomes 1 and 3. Correct? Yeah. Now yeah, tell me, what was the first topic? First topic was what? Atomic stencil. What you have to remember in this? Atomic stenciling. Iodide is used to hide, and unmasked is where the polymers get attached. This will help us form proper 3D structures. Correct? This is what atomic structuring is all about. Then next, cloud seeding. Cloud seeding. What we were doing this, in this we were using some different kinds of salts or nuclei. Salts or nuclei. Examples? Yes. Silver, iodine, and potassium iodide, and more sodium chloride and CO2 dry. So all these we can use, and you understand what it will do? It will help coalesce water droplets, and then it will lead to rain. Now this rain can help you fight drought, fight pollution, or pre-pon events, whatever. So all these things can be done. This is about cloud seeding. Then third is what? AWS. In AWS you need to know about major cloud computing systems. What are they? Three are there. One is by Amazon, one is by Google, and one is by Microsoft. Correct? Now most of it, Amazon covers 32% of it. Now because of this outage, there are issues like many things are dependent on this. So we should make our systems, first thing is hybrid, then distributed. Hybrid means some of the parts should be stored in our local systems, other is distribute between these three, and the last is make our own. For example, that Meghraj. So all these that we have made. So make our own for our own data storage and data centers. Then next atom bomb. True random numbers. Here what you have to remember, two kinds of number are there, pseudo random numbers and true random numbers. This is based on some kind of algorithm, correct, and it can be backtracked like this. This is based on physical phenomena, especially at quantum level. So this cannot be backtracked like this, because anyway we also don't understand the systems, so we cannot backtrack it. This will lead to a what? Unbreakable security. Okay, and this can be generated using two systems. One is time separation and one is spatial separation. That's it. Last is what? Lunar exosphere. In this we have a Chandrayaan 2. In Chandrayaan 2 there is a this spectrometer observed the effect of coronal mass ejection on lunar exosurface. That's it. This much only you have to remember. Okay, that's it for the class. Thank you.